Good morning, all of you. My name is Vishaldeep Bansal. As you see, Gate 2024 notice has been released, and I hope you have seen the notification and syllabus too. I will start with electronic devices and circuits. Let us start the session. See, what are electronic devices? What are electronic devices? Electronic devices. These are devices basically that operates by the flow of electron that operates by controlling the flow of electrons controlling the flow of electrons controlling the flow of electrons. As you see, an atom consists of nucleus. An atom consists of nucleus or positive charge. An atom consists of nucleus or positive charge which includes proton, which includes protons and neutrons, which includes proton and neutrons, and that contains all the mass. So, in atom, all the mass is concentrated around the nucleus. Electrons revolve in fixed orbit. Electron revolves in fixed orbit. Electron revolves in fixed orbit. Okay. As you see, electron revolves in fixed orbit, and these orbits have different energy. These orbits have different energy. These orbits have different energy. The force between two atoms or ions. Force between two atoms or ions is function of distance. Force between two atoms or ions is function of distance. Please keep in mind. Okay. Also write one more point. Force is repulsive when separation between atoms is small. Force is repulsive when separation between atoms is small, and it is attractive when separation between atoms is large. Okay. Force is repulsive when separation between atoms is small, and attractive when separation D is large. When separation D is large. And these bonding forces between atoms, so this is A atom, this is B atom, and these bonding forces, what are the bonding forces is called chemical bond. These bonding forces between atoms is called chemical bond, and by the process by which these bonds are held, The process by which these bonds are held is called bonding. Is called bonding. Is called bonding. Okay. Write one more point. For an isolated atom. For an isolated atom. For an isolated atom, electrons have discrete energy. For an isolated atom, electrons have discrete energy. Okay. For an isolated atom, electrons have discrete energy. Write one formula. Energy of hydrogen atom is given by formula m naught q to power 4 upon 8 epsilon naught square h square n square. When will you evaluate it? Its value comes minus 13.6 divided by n square. Electron volt. Electron volt. As you should have two copies. One copy for notes and one copy for formula. And in formula book you have to written these formulas separately. Okay. Here m node is free electronic mass. Here m node is free electronics mass. Q is charge, and epsilon node is free space permittivity. Epsilon node is free space permittivity. What is H here? H is Planck's constant. H is Planck constant. What is N here? N is principal quantum number. N is principal quantum number. Okay. Here unit is electron volt. Here unit is electron volt. What is electron volt? What is electron volt? Electron volt is energy unit corresponding to electron volt. It is energy unit. As you see, I have written energy of hydrogen ion. It is energy unit. It is energy unit corresponding to. It is energy unit corresponding to energy gained by electron. Energy gained by electron when potential increased by 1 volt. When potential increased by 1 volt. Okay. As I have seen in you have seen in previous slide, discrete energy level in atom around the nucleus. There are discrete energy level, and these levels are calculated by putting n is equal to 1, 2, 3 up to n minus 1. Okay, up to n minus 1. Please write one more formula. Kinetic energy gained by an electron is equal to potential energy lost by an electron. Here I am not deriving these formulas. how this came. Okay, our target is to clear the gate, not doing PhD on it. Okay, here I am writing only formulas, not derivation. Okay, so kinetic energy gained by an electron, kinetic energy gained by an electron is equal to potential energy lost by an electron. Kinetic energy, how much it will gain? Half mv square. Potential energy is equal to q into v. Then velocity of electron is equal to v. Velocity of an electron b is equal to root 2 q b upon m. Q is a charge, m mass of electron, and v is potential, and unit of velocity is meter per second. Okay, add this formula in formula notebook. Okay, add this formula. Consider two points A and B in space. I am considering 2 points A and B. I am considering 2 points A and B in space. Okay, and assuming that B is at higher potential. B is at higher potential. Okay, and then point A. B is at higher potential than point A. Okay, then previous formula that we have written will be modified as QBBA. QBBA. B is at higher potential, so suffix B will be written first. B is at higher potential. Half m v a square minus half m b b square. Okay, remember this formula. QBBA is equal to half mbb a square minus half mbb square, and this unit is this quantity QBBA. Its unit will be joules. This unit will be joules, and BA is initial speed. BB is final speed. BA is initial speed. BB is final speed. Okay, I am considering 2 points A and B in space. 2 points, these are not items. I am considering just 2 points. These are just points. I am considering when an electron will move from A point to B point, its velocity is considered. Okay, initial velocity A at point A and final velocity at point B. Okay, and this potential energy between 2 points is multiplied by charge. Potential energy between 2 points equals to potential multiplied by charge, that is represented by QBBA. That is represented by QBBA. Here I am electron is traveling from point A to B. Electron is traveling from point A to B. For this I am considering electron with initial speed BA. Electron with initial speed BA. Suppose electron I am considering at rest. If I am considering electron is at rest, then value comes is equal to this one. Okay, then the value for an electron at starting at rest, for an electron starting at rest, starting at rest. Then velocity is given as 5.93 into 10 raised to power 5 square root of potential. Okay, write this formula also in notebook. Write this formula also in formula notebook. Okay, let us see this. Let us see this question. Let us see this question. What is given? 100 Bohr electrons are introduced at a 100 Bohr electron. 100 Bohr. I have considered 2 points in previous slide. Okay, 2 points A to B. A to B. Here question is given 100 Bohr electrons are introduced at A into uniform electric field of 10 raised to power 4 volt per meter as shown in figure. The electrons are to emerge at point B in time. Electrons are taking time of 4.77 nanosecond traveling from A point to B point. Electrons are taking time 4.77 nanosecond from point A to B. And what is asking? Question is asking about what will be distance AB. What will be distance AB, and what angle does electron beam make with horizontal? Since electron is projected in projectile motion, electron is being projected in projectile motion and following the parabolic path. Okay, as we have written, initial electron velocity initial electron velocity V naught is given by formula 5.93 is to 10 raised to power root of B. Okay, root of B, and this value will come at 100 potential. 100 volt electrons are introduced at a 100 volt. So 5.93 is to 10 raised to power 6 meter per second. Initial electron velocity we have calculated. Okay, now and next we have to calculate distance AB. Okay, distance AB. Suppose this angle is theta, then this will be B naught cos theta. This will be B naught cos theta. This will be B naught cos theta, and this will be 90 minus theta, B naught sin theta. Okay, then angle A, distance AB we have to calculate. Distance formula is speed into time. V naught, this component, V naught velocity, initial velocity component, V naught cos theta into time. Okay, 5.93 is to 10 raised to power 6 into what is time? Time is given 4.77 nanosecond. Electron takes from traveling from A to B, 4.77 nanosecond, and nanosecond value is 10 raised to power minus 9. Okay, calculate this. As you see, this is almost 6, this is 5. 6 is to 5, 30, and this is not exact 6, this is not exact 5. Okay, so almost it is around 28 to 29. Okay, 28 something. Then adjust this power, 10 raised to power 6 minus 10 raised to power 9, 10 raised to power minus 3, and 128 divided by 10, 2.8 something, 2.8 something, 2.8 exact. If you will exact calculate, it will come out to be 2.83 10 raised to power minus 2 cos theta. Here attach it, cos theta, b naught cos theta into t. Distance AB, we have calculated distance AB 2.83, 2.83 into 10 raised to power minus 2 cos theta. Okay. Next is asking about angle. Okay, angle is asking about. See this is B naught, this is B naught, this is theta, this is B naught sin theta. Here, as you have studied in 12th class or 11th class, here when will electron will move from point A to B, from point A to B, then this component will also work. This is gravity, half A by T square, okay. So y component, if you evaluate, if y component, if you evaluate, then it is given as V naught sin theta into t, V naught sin theta into t minus half A by T square. V naught acceleration in y direction, is constant, okay. And y is equal to 0, and see this point, and see y is equal to, at x-axis y is equal to 0, at x-axis y is equal to 0, okay. Y is equal to 0 at point B, y is equal to 0 at point B, then V naught sin theta is equal to half A by T, V naught sin theta is equal to A by T, okay. And this is A by T, okay. And when will you evaluate it? It comes as, please, E by m into t, E by m into t, okay. For reference, please keep remember this A y value is E by m in E by m, A y E by m. Please note it in formula notebook, okay. A y component, only note it, acceleration is given by E by m, okay. E by m. Here electron charge E 1.76 into 10 raised to power 11. 1.76 this value comes out to be, okay. Half 1.76 electron E by m ratio, 1.76 10 raised to power m. E 1.6 into 10 raised to power minus 19, E 1.6 into 10 raised to power minus 19, and mass of electron 9.1 into 10 raised to power minus 31 kg, mass of electron, okay. Adjust it, and this value comes out to be 1.76 into 10 raised to power 11, 1.76 into 10 raised to power 11, and into time value. What is time value? time 4.77 nanosecond. 4.77 into 10 raised to power minus 9. 10 raised to power minus 9. Calculate it. Calculate it. This is almost cancelled out. Okay, this is almost cancelled out, and this value exactly comes out to be 4.20 into 10 raised to power 6 meter per second. Okay, 4.6. Okay, and sine theta, sine theta, sine theta, sine theta value comes out to be, sine theta value comes out to be y by AB, y by x, y by x. Okay, y by x sine theta. Okay, this value is cos theta and this value is sine theta. Okay, sine theta is comes out to be y by x, and y by x means 4.20 into 10 raised to power 6 divided by AB. AB value we have calculated 5.93 into 10 raised to power 6. Okay, 5.93. See here, see, we have calculated V naught sine theta is equal to 4.20 into 10 raised to power 6. Okay, and this, and yes, we have calculated V naught sine theta. V naught sine theta is equal to 4.20 to 10 raised to power 6. Okay, and here sine theta we are calculating. Sine theta is equal to 4.20 into 10 raised to power 6 divided by V naught. V naught we have calculated 5.93 into 10 raised to power 6. Here I am writing this. Okay, 4.20 into 10 raised to power 6 divided by 5.93 into 10 raised to power 6. Okay, and this comes out to be near around 0.7077. Our angles comes out to be theta is equal to 45 degree. Theta is equal to 45 degree. Okay, and next, please write in notes electric field intensity. Electric field intensity. Electric field intensity resulting, electric field intensity resulting from applied, potential difference. Electric field intensity resulting from applied potential difference B between two plates, of capacitor, here I am considering two plates, okay, of capacitor, and distance between plates is D, and distance between the plates is D. This is Z direction. Okay, this is electric field intensity. This is origin point, Y direction, X direction. Okay, electric field intensity resulting from applied potential difference B between two plates of capacitor. Electric field in X direction is given by formula minus B upon X minus X naught is equal to minus B upon D, minus B upon D. I am not deriving this, only writing this formula. Minus B upon X. Suppose this point is X, X minus X node, and potential is B. Potential is B. Since I am considering this side electric field in X direction, okay, minus I have substituted here. Ex electric field is volt per meter. As we have seen in earlier problem, electric field was given 10 raised to power 4 volt per meter. So its unit is volt per meter. D is distance between capacitor plates. D is distance between capacitor plates, and its unit is meter. Its unit is meter. In general, field vary with the distance. Field varies with distance. So correct result is given below. Electric field is given as minus dB by dx. Electric field varies with distance. In general, Ex is given as minus dB by dx. Okay. See next question. Question number 2. What is given? An electron starts at rest on one plate of parallel plate capacitor whose plates are 5 cm apart. Whose plates are 5 cm apart. The applied voltage is 0. Applied voltage here V is 0 when electron is released. It increases linearly from 0 to 10 volt in 0.1 microsecond. If opposite plate is positive, what speed will electron attain in 50 nanosecond? Okay. Question is asking about speed, and second question is where will be at end of this time. Third question is asking about with what speed will electron strike the positive plate. Three questions being asked. Okay, let us see. Here electric field is given or not? Not. First to evaluate electric field. Electric field E is equal to V by D, and V is given. Yes, 0 to it increases from 0 to 10 volt. Okay, minus V by D is 0 to 10 volt, and distance between them is 5 centimeter converted into meter. Okay, electric field V by D, and also I am multiplying this by this is bearing. Electric field is bearing, so multiplying by T and divided by also T to make it unitless, to make this quantity as unitless. 10 raised to power minus 7 in 0.1 microsecond. Since applied voltage is 0 at instant, the electron is released and it increases linearly. Linearly variation. So this is x is equal to t at. This is linearly variation with respect to t, and making this quantity, not overall quantity, this quantity unitless. Okay, so that our unit will remain volt per meter. Electric field unit is volt per meter, and calculate it 2 into 10 raised to power 9 T volt per meter. Okay. Acceleration formula is velocity upon time. When we differentiate it, it is given by dv by dt. Since I am considering along x direction, dv by dt, and acceleration, another formula is also we know from childhood, that is force upon mass. Force in x direction upon mass. And also E by m, E by m ratio we have seen 1.76 into 10 raised to power 11, and electric field 2.2 into 10 raised to power 9 into T. Okay, 1.76 into 2 multiplied 3.52. Okay, 3.52 into 10 raised to power 20 T meter per second square. Acceleration unit is meter per second square. Okay, then if you want to calculate velocity in x direction, then you will integrate it. Acceleration, you will integrate it x dt from 0 to t. Okay, 0 to t. Acceleration comes out to be 3.52 into 10 raised to power 20. When will you integrate, it comes out to be t square by 2. Okay, and this is value velocity. This is value of velocity. And another thing in question is given speed. Speed is asking about speed. Velocity is speed. Speed will electron, if opposite plate is positive, what speed will electron attain? Speed. So in 15 nanosecond. Here we will fill the unit. Here we will fill the unit at unit. Sorry, not unit. It's value. T value. 5 point. I am converting 50 into 10 raised to power minus 9 and 110 in denominator. 5 is to 10 raised to power minus 8. Okay, and Vx is equal to sorry, when will you put, when we are putting this value, when we are putting the value 5 is to 10 raised to power minus 2 8 into this equation, then Vx value comes out to be 4.40 into 10 raised to power minus 5 meter per second. 4.40 into 10 raised to power 5 meter per second. Okay, and Vx value comes out to be 4.40 into 10 raised to power 5 meter per, and these two questions will be your assignment. Where will it be at end of this time, and with what speed will electron strike at positive plate? This will be your assignment. If you could not solve this, then you can ask me personally. Okay, you can ask me these personally. Okay, next let us see third question. Third question. A 100 electron board hydrogen ion is released in center O of plates in coordinate system as shown in figure. Figure is not given or not? Okay, figure is not attached. No problem. The voltage BD between plates varies linearly from 0 to 50 volt in 10 raised to power minus 7 second, then drops immediately to 0 and remains at 0. Separation between plates D is equal to 2 cm. Length of plates L is equal to 5 cm. If ion enters region between plates at T is equal to 0, how far will it be displaced from x-axis upon emergence between plates? Okay. A 100 electron volt potential is given. 100 electron volt is placed in the center of plates. Two plates are given. Okay, capacitor, here is capacitor only. 100 electron volt hydrogen ion in released in center of plates in coordinate system as shown in figure. Figure is not given, but we are making the figure as this. The voltage BD between plates varies linearly from 0 to 20 volt. This question is also similar to previous question, but somehow difference is there. The voltage BD between plates varies. Voltage BD between this plate, because I am assuming this plate A, this plate as B. The voltage is varying from 0 to 50 volt in 10 raised to power minus 7 second. In how much time is taking? 10 raised to power minus 7 second. Okay, and then drops immediately to 0 and remains at 0. And voltage here, after linear verification from 0 to 50 volt, voltage comes out to be finally 0 and remains at finally 0. Separation between two plates is D is equal to 2 cm. D is equal to 2 cm and length of plates L is equal to 5 cm. Length of plates, this is given. Length of plate, this length is given 5 cm. If ion enters the region between plates at time t is equal to 0, how far will be displaced from x-axis? As you may have doubt, sir, in ADC you are teaching this question. All these important students, see, these kinds of questions have not been asked till date, but in future these may be asked. Okay, so you should be ready with every concept. See, here I am calculating velocity of hydrogen ion along x-axis. Velocity of hydrogen ion along x-axis, as I have written earlier. Velocity formula root 2q b upon m. 2q into potential upon mass of hydrogen ion. Okay, and this 2 into 1.6 into 10 raised to power minus 19 into 100 electron volt hydrogen ion. Potential is 100 electron volt. Okay, mass of hydrogen ion 1.676 is to 10 raised to power minus 27. Evaluate it. I already have evaluated it, so I am directly writing it. 4.37 into 10 raised to power 5 meter per second. Okay, 4.37 is to 10 raised to power minus 5 meter, 10 raised to power 5 meter per second. Okay, also this formula you have written in formula notebook. Okay, and one more formula, write it. Displacement in x direction, vector distance like a distance, it is shortest distance, it is shortest distance, shortest distance formula, velocity into time, and Vox is 4.37 into 10 raised to power 5 into time is given or not? Yes, 10 raised to power minus 7, and this value comes out to be 4.37 is to 10 raised to power minus 2 meter. Okay, now one more thing you have to remember, y value, you have to remember, y value is given as minus 4.75. This is standard result, given in one of the popular group, given in one of the popular book. Okay, this is standard result. Okay, y is equal to minus 4.75 x cube. You should write this value in formula book also, in formula book. Okay, what to write? Make this diagram. Okay, make this diagram and write to this is capacitor plates, and this distance is d, okay, and length of plates is L, write it this formula, y is equal to minus 4.76 x cube. If you will drive this, how comes out to be? This is very long expression, for gate point of view. This is not required, only remember this formula, y relation with x. Okay, also displacement, as asking in question, asking if the ion enter the region between plates at time t is equal to 0, how far will be displayed from x-axis? How far will be displayed from x-axis? I mean displacement in y direction is asking. Also write one more formula. Displacement in y direction is given by formula minus 14.2 x1 square L minus x1 plus y1. This formula you should write also in formula notebook. Okay, minus 14.26 x1 square L minus x1 plus y1. Okay, minus 14.26 x1 square, x1 displacement in x direction, x1 is also write formula, x1 is displacement in x direction, that comes out to be 4.37 into 10 raised to power minus 2 square into L minus x. What is length of plates given? 5 centimeter. 5 into 10 raised to power minus 2 minus 4.37 into 10 raised to power minus 2. Okay, plus y1, and y1 value will be calculated from this. Okay, y1 in terms of x1, and this will be minus 4.75 into x cube 4.37 in minus 10. In gate exam this complicated value will not be given, only easy values will be given. Okay, so when will you evaluate it? I have already evaluated it, and this value comes out to be 0.056 centimeter. 0.056 minus 0.056 centimeter. Okay, Next question. Next question number 4. Question number 4. Two lane parallel plates A and B are placed 8 mm apart. Two plates are parallel plate capacitor and 8 mm apart. Okay, and plate B is 300 volt more positive than plate A. Plate B is 300 volt more positive than plate A. The electron travels from plate A to plate B with initial velocity of 1 is to 10 raised to power 6 meter per second. Calculate the time of travel. Calculate the time of travel. Okay. In notes, in formula notebook, write one more formula. Although it is not required, but you have to remember it. Speed required by electron. Is V is equal to here. I have already written V is equal to 2qV by M, but here I am adding V initial as initial velocity is given. Initially I am assuming electron is at rest, but here electron travels from plate A to plate B with initial velocity. When electron travels from A to B, this having initial velocity, okay. So this value, evaluate it, 2 into 1.6 into 10 raised to power minus 19, and potential is given 300 volt more positive, and mass 9.1 is to 10 raised to power minus 31 plus 1 into 10 raised to power 6 square. And when I have evaluated already this value, 10.33 is to 10 raised to power 6 meter per second. Okay, then average velocity is given as initial plus final divided by 2, and initial velocity is 1 is to 10 raised to power 6, and final velocity is 10.33 is to 10 raised to power 6 divided by 2, and this value comes out to be 5.665 is to 10 raised to power 6 meter per second. And time is distance upon average velocity. Distance is given or not? 8 mm apart. 8 mm apart. Average velocity we have just calculated 5.665 into 10 raised to power 6. Okay, and this comes out to be 1.4 into 10 raised to power minus 9 second. Okay, this type of question comes in numerical value. This type of question comes in GATE as numerical type question, and it may written as calculate the time of travel if its value comes out to be x into 10 raised to power minus 9 second. Okay, then x value, find the value of x, find f. Then what will you do? X is 1.4, and IIT may return its range as 1.2 to 1.5 something. Okay, 1.2 to 1.5 something. Okay, next one more concept is there. And more concept, remember, deflection. Although although this concept comes in electronics measurement and instrument, but this is also expected in upcoming exams also, or in gate exams also. This is expected. This kind of concept can be asked. Okay, deflection on screen of CRT. Deflection of CRT is directly proportional to deflecting voltage between the plates. Deflecting voltage between the plates. Okay, deflecting voltage between the plates. CRT. Deflecting voltage between the plates. Okay, CRT having two types of plate, vertical deflection plate and horizontal deflection plates. Okay, vertical deflection plates and horizontal deflection plates. Vertical deflection plates and horizontal deflection plates. Okay, so deflection, write this formula. Deflection is equal to small l into capital L Vd upon 2dVA. Deflection formula, deflection small l capital L Vd, and capital L is screen distance. This is screen. Here I am making the diagram of cathode ray tube. Screen distance from center of plates. Small l is length of deflection plates. Also, remember one more formula: electrostatic deflection sensitivity. Electrostatic deflection sensitivity of CRT cathode ray tube is given as electrostatic deflection sensitivity is given as d upon Vd. Deflection upon Vd. Okay, what is Vd here? Vd is deflecting voltage. Vd is deflecting voltage, and when you divide by Vd, this value is small l, capital L upon 2dVA. 2d is VA. 2d VA. This is VA is anode voltage. And also write angle of deflection theta in terms of tan theta. We will write this formula in terms of tan theta, d upon L, capital L minus small l. Okay. See. Okay. And these three formulas also you should write in formula notebook. Okay, these three formula also you should write in formula notebook. Okay, and here d is distance between plates. Okay, d is distance between plates. See question number 5. Question number 5. What is it is telling about? Question number 5. An electrostatic cathode ray tube has final anode voltage VA of 600 volt. What is given? VA is given 600 volt. Deflection plates are 3.5 centimeter long. Small l given 3.5 centimeter long. Okay. Next, 0.8 centimeter apart. Distance between plates is 0.8 centimeter. Okay. Next, screen is a distance of 20 centimeter. Capital L. Screen distance from center of plates is given 20 centimeter. Next, a voltage of 20 volt is applied to deflection plate. यानी कि deflection plates deflecting voltage is given. Deflecting voltage is given 20 volt. Deflecting voltage is given 20 volt. What is asking about? Velocity of electron on reaching the field. Velocity of electron. Velocity of electron. Formula is velocity of electron. We have written already 2 to 3 times. Velocity of electron is formula is 2q BA, potential 2q BA upon m. Okay, 2q BA upon, okay, this value comes out to be 14.35 into 10 raised to power 6 meter per second. Okay, next, acceleration due to deflection plate. As you have seen, acceleration E by m, E by m. Okay, this value E by m, this value we have calculated. Okay, and E by m 1.76 raised to 10 raised to power 11. E, electric field V by D, deflecting voltage upon D, 1.76 raised to 10 raised to power. Okay, deflecting voltage is 20 upon distance 0.8 into 10 raised to power minus 2, and this comes out to be 10 raised to power minus 2, 10 raised to power 43.95 raised to 10 raised to power 13, and acceleration unit is meter per second square. Okay, next is asking about deflection produced on screen. Deflection formula we have already written. I small l capital L small l capital L and BD upon 2 dVA, small l capital L 2 dVA, and all value is given. Small l is given, capital L is given, BD is given, and D is given, BA is given. Okay, put these values and this result come out to be. Verify this result as an assignment. Verify this result as an assignment. And deflection sensitivity S is equal to D upon VD, and this value comes out to be 0.0725 centimeter per volt. Deflection sensitivity. Verify this result also as an assignment. Okay, as an assignment. Okay, next write notes. Next write in notes thermal voltage. Next write in notes thermal voltage. Thermal voltage. Okay, thermal voltage BT. Thermal voltage BT, and BT is given as Write this formula K bar T upon Q volts. K bar T upon Q. Write this formula in formula notebook. BT K bar T divided by Q. T is temperature. T is temperature in Kelvin. T is temperature in Kelvin, and Q is charge. And K bar value is 1.38 is to 10 raised to power minus 23 joule per Kelvin. And K bar is, what is this? Boltzmann constant. This is Boltzmann constant in joule per degree Kelvin. Joule per degree Kelvin. Okay. In some books, K value is also given. K value is also given. That is, K value is K bar square divided by Q. Remember this. Also write in notes. K is equal to K bar square divided by Q, and K value is 8.62. Don't confuse. When I am saying, don't confuse. This is in electron volt per degree Kelvin. This is in electron volt, while this is in joules. 8.62 into 10 raised to power minus 5 electron volt. And BT value is also given as T upon 11,600 volt. T upon 11,600 volt. 11,600 volt. If T is 0, then BT is 0. If T is 27 degrees Celsius, room temperature 300 Kelvin, 20 Celsius to Kelvin plus 273 300 Kelvin. BT value comes out to be 300 upon 11,600. This value comes out to be 0.0258 volt. Okay. And BT in millivolt, 2.5 millivolt, nearly 26 millivolt. Remember this value also. Thermal voltage at 300 degree Kelvin is 26 millivolt. Okay. Standard room temperature. If anyone is asking what will be thermal voltage at room temperature, then your answer will be, sir, it will be 26 millivolt. Okay. If by default temperature is considered as 300 Kelvin, by default temperature is considered as 300 Kelvin. If not given, then you have to write 300 Kelvin. Okay. And okay, one more point you will write. Theory of relativity says Einstein equation W is equal to mc square. W, and people write as E is equal to mc square. Don't change the notation. E is equal to mc square. This is total energy. This unit is joule. This is mass. This is velocity in meter per second. Velocity of light in vacuum in unit is meter per second. As like earlier, I am considering if electron is starting from point A, and with zero velocity and reaches point B with velocity VB, and with the velocity B, then increase in energy of particle is given as electron volt. increase in energy of particle must be given by expression electron volt, and this electron volt is energy, and electron volt is energy. This what I am considering electron movement from point A to point B, and this is given as mc square minus m naught c square, mc square minus m naught c square. Okay, here m naught is rest mass, also called as, in some books is written as electrostatic mass, okay. This m node is independent of velocity. This m node is independent of velocity. Total mass of particle, total mass m of particle is given as, total mass m of particle is given as m is equal to m node upon root 1 minus b square upon c square. Write this formula also in formula notebook. M is equal to m node upon square root of 1 minus b square divided by c square. Write this formula. Okay. Decrease in potential energy is equal to decrease in potential energy is equal to increase in kinetic energy. Rational energy is given as m naught c square, and this formula you will write also 1 minus b square by c square, 1 minus b square by c square minus and minus 1 this formula you will also write in formula notebook. Okay. Decrease in potential energy is equal to increase in kinetic energy. And what is increase in kinetic energy? M naught c square, in bracket write it 1 divided by root 1 minus b square by c square minus 1. Okay. Also write one more formula. True velocity of particle is given as v is equal to c 1 minus 1 plus v n square upon 2c square and vn square upon 2c square whole square, and this value comes out under square root. True velocity of particle v is equal to c square root of 1 minus 1 divided by 1 minus 1 divided by 1 plus bn square upon 2c square the power square. bn is root 2 ev upon m naught. Okay, this value we have already written it. Okay. Next is energy band. Write in notes. Energy band. Coupling of shell electron results in closely spaced energy state. Closely spaced energy states. Coupling of shell electron results in closely spaced energy state. Okay. And second point you will write electrons in outermost orbit. Electrons of outermost orbit. Forms electrons in outermost form valence band. Electrons in outermost orbit form valence band. Free electrons having high energy. Electrons having high energy forms conduction band. Electrons of outermost orbit form valence band. Free electrons having high energy form conduction band. These 2 points you will remember. Okay. Next is energy gap. Energy gap is given and by notation Eg. Electron energy gap. Okay. The writing points. The region between valence band and conduction band is called forbidden band. Forbidden energy gap or band gap. Forbidden energy gap or band gap. Okay. Region between valence band and conduction band is called forbidden energy gap or band gap. Okay. And this band gap value, this is basically valence band, this is conduction band, and region between valence band and conduction band is forbidden energy band. This value for insulators Eg, for insulator Eg is greater than 5. In insulator band gap is large, while in semiconductor is value 0.1 electron volt to 0.5 electron volt, in the range of 0.1 electron volt to 0.5 electron volt. In case of conductor, Eg is less than 0.0 electron volt. Eg is less than 0.0 electron volt. Okay. Eg energy band gap, Eg node. One more point you will write Eg node. Energy gap at 0 Kelvin. Eg room temperature. Energy gap at 300 Kelvin. Energy gap at 300 Kelvin. For this value you will write also in formula notebook. Eg node for germanium is given as 0.785 electron volt, and for silicon it is 1.21 electron volt. Energy band gap at room temperature for germanium 0.72 electron volt, and for silicon 1.1 electron volt. This will also write in formula notebook. Okay, also write one more point. Energy band in germanium and silicon. Energy band in germanium and silicon decreases. Energy band in germanium and silicon decreases with increasing temperature. Okay, energy band in germanium and silicon decreases with increasing temperature. Eg is inversely proportional to temperature. Energy Eg thus is inversely proportional to temperature. Also write one more point. Eg at any temperature. Eg at any temperature is given as Eg at any temperature is given as Eg at temperature T. Eg at temperature 0 Kelvin minus beta node T. Eg at temperature T is equal to Eg at temperature 0 Kelvin minus beta node T in electron volt. T is in Kelvin, beta node T is in Kelvin, where beta node is material constant. Beta node is material constant. Its value is given as EB divided by K. For germanium, Eg at temperature T is Eg node 0.785 at temperature 0 Kelvin. For germanium, beta node value is 2.2 into 10 raised to power minus 4 into T. Beta node into T. Okay, beta node into T. Beta node for germanium is 2.2 into 10 raised to power minus 4. 2.2 into minus 10 raised to power minus 4. For silicon, Eg energy band gap at temperature T, energy band gap at temperature 0 Kelvin. For silicon 1.21 minus 3.6 is to 10 raised to power minus 4 T. Okay, beta node for silicon is given as beta node for silicon is given as 3.6 into 10 raised to power minus 4. 3.6 into 10 raised to power minus 4. Okay. Note. Write a note. If Eg is large, if Eg value is large, then semiconductor material is suitable for high temperature applications. If Eg is large, then semiconductor material is suitable for high temperatures applications. Okay, high temperature applications. Okay, energy band diagram. In case of metals, okay, energy band diagram. In case of metals, Eg is 0. In case of metals, Eg is 0. Eg is 0, and this is valence band and this is conduction band. Eg is 0. In metals, in metals, in metals, free electrons are available. Free electrons are available in high amount. Metals are good conductors of electricity. Metals are good conductors of electricity, even at 0 Kelvin, even at 0 degree Kelvin. Okay, what will happen? This is at 0 Kelvin. This is at 0 Kelvin. This band diagram is at 0 Kelvin, and suppose at 300 degree Kelvin room temperature, what will happen in case of metals? Overlapping will occur. Overlapping of valence band and conduction band. Overlapping of valence band and conduction band. These band will overlap. Okay, these bands will overlap at 0 Kelvin, and this much is conduction band and this much is valence band. These bands will overlap at 300 degree Kelvin. At 300 degree Kelvin. Okay, what will effect of overlapping? Right, one more point. Overlapping increases with increase in temperature. If you will increase temperature, then overlapping will increase. Also overlapping exhibit positive temperature coefficient of resistance. Also overlapping exhibits positive temperature coefficient of resistance. As you have seen in 12th class, and some of you may know, metals have positive temperature coefficient of resistance. Okay, as metals having positive temperature coefficient of resistance, so in case of metal, resistance value increases with increasing temperature. In case of metal, resistance value increases with increase in temperature. And resistance value is given by formula RT is equal to R naught 1 plus alpha T. Okay, also in case of metals, In case of metals, free electron concentration is nearly 10 raised to power 22 10 raised to power 22 10 raised to power 22 per meter cube. 10 raised to power 22 per meter cube. This free electron concentration independent of temperature. In case of metals, free electron concentration is equal to 10 raised to power 28 per meter cube, and this is independent of temperature. Next, Eg sorry, in next slide we will written Eg in semiconductors. These are materials basically whose conductivity lies between metals and insulators. Okay, for semiconductor, Eg is small. For Eg is in range, we have seen 0.1 electron volt to 0.5 electron, 1.3 electron volt. Okay, Eg in case of semiconductor. This is conduction band, valence band. Okay, at 0 Kelvin, carrier concentration is 0. Also, conductivity. In upcoming lectures we will see conductivity is dependent on carrier concentration. If carrier concentration is 0, conductivity will be 0. So at 0 Kelvin, semiconductor air will be empty. Semiconductor at 0 Kelvin will behave like an insulator. Okay, at 0 Kelvin, carrier concentration is 0, conductivity is 0. So at 0 Kelvin, it will behave as an insulator. Semiconductor exhibits property of covalent bonding. In semiconductor makes covalent bonding is basically sharing of electrons. Covalent bonding is basically sharing of electron, and one more bond is ionic bond. Ionic bond is basically transfer of electron. Covalent bonding is exhibited by semiconductor when temperature increases. These covalent bonds will break. This will result in electron hole pair EHP electron hole pair. This will result in EHP electron hole pair. When this will result in electron hole pair, this will increase the conductivity. This will increase the conductivity of semiconductor. More electrons will conduct in a crystal. More electrons will conduct in a crystal. Okay, more electron will conduct. It will increase the conductivity in case of semiconductor. In case of semiconductor. In case of semiconductor, carrier concentration increases with increase in temperature. In case of semiconductor, carrier concentration increases with increase in temperature, and Ni square carrier concentration is directly proportional to temperature raised to power cube. Ni square is directly proportional to T cube. Okay. Energy gap Eg of silicon decreases. Energy gap Eg of silicon decreases with increase in temperature. Energy gap Eg of silicon decreases with increase in temperature at a rate of 3.6 is to 10 raised to power minus 4 electron volt per Kelvin. 3.6 is to 10 raised to power minus 4 electron volt per Kelvin, which is nothing but beta value, which is nothing but beta node value. Okay, as we have seen, Eg at temperature T is 1.321 3.6 into 10 raised to power minus T for silicon and 0.785 minus 2.23 into 10 raised to power minus T for germanium. Energy, as you see, energy gap for silicon is more for germanium. Energy gap for silicon is more for germanium. So energy gap for silicon is more for germanium is greater than energy gap for germanium. So silicon can be operated at high temperature. Energy gap is large, so silicon can be operated at high temperature. Next we will see energy gap in case of insulator. Energy gap in case of insulator. Okay, this conduction band will be empty. At any temperature, and this energy gap will be greater than 5 electron volt. Large energy band gap. Insulator, as we have seen, Semiconductors having covalent bonding, while insulators having ionic bonding. Ionic insulators having ionic bonding. Also, one more point. Insulators are bad conductor. Also, bad conductors. Not like a metals. Insulators are bad conductors of electric current, electricity within normal temperature work within normal temperature. Insulators are bad conductor of current within normal temperatures. Okay. Next is energy band gap value. You will remember energy band gap value. You will remember for some another elements also. Sorry, energy band gap value for gallium arsenide, Eg. Some another elements 1.43. Gallium phosphide is 2.3, and one more is there, just indium phosphide 1.35. Indium phosphide is 1.35, and indium phosphide, and one more is there, indium gallium arsenide. This value is 0.75. And one more value is gallium aluminium arsenide 1.8. Gallium aluminium arsenide 1.8. Okay. Next. Okay. Pure semi, as you may have studied in BTech, some of you may know pure semiconductors or intrinsic semiconductor. Pure semiconductor means is having no impurity. Okay, and these are a group of 4 elements. Okay, these are group 4 elements, and most commonly used are silicon and germanium. Also, note this one more point, and you have seen in case of IC fabrication, in case of IC fabrication, silicon is preferred. Why? Okay, then write in points. Reason is primary reason. Silicon is available in abundance. Silicon is available in quite large amount. In abundance. Also, second point, it is stable at higher temperature. Next point. Next is dielectric layer of SiO2 can be easily fabricated on silicon chip. Okay. Also, write one more point. It has small reverse saturation current. saturation current. It has small reverse saturation current, and as earlier we have seen, energy band gap of silicon is large compared to germanium. Large band gap. Also write better conductivity, better heat conductivity. Okay. Also one more point is there, but that is not needed, but write it. It is possible to provide electrical isolation in silicon chips. Okay, in case of silicon chips. Next is mobility of charge carriers. Next point is mobility of charge carriers. Mobility is defined as drift velocity per unit electric field. Mobility is defined as drift velocity Vd per unit electric field intensity E. Mu is equal to Bd divided by E. Okay, and mu is a mobility. Okay, and unit will be meter square divided by volt second. Meter square divided by volt second. Okay, drift velocity unit is Bd. Drift velocity unit is meter per second. Okay, electric field is volt per meter into meter per volt. When will it goes in meter per volt per meter into meter per volt. Okay, and then its unit is meter per volt second. Meter square divided by volt second, or centimeter square divided by volt second. Centimeter square divided by volt second. Okay, mobility. What is significance of mobility? It indicates what is significance of mobility. It indicates how fast electron or hole moving from one place to another. Electron moving one place to another. It indicates how fast electron is moving. What is significance of mobility? Then you will write, sir, it will indicate how fast electron or hole will be moving from one place to another. Large mobility means indicates higher conductivity. Large mobility means higher conductivity. Okay, large mobility means higher conductivity. Also write drift velocity will always greater than normal velocity. Drift velocity will always be greater than normal velocity. Drift velocity will always be greater than normal velocity. Let S see electron mobility is represented by mu n. Hole mobility is represented by mu p. In case of germanium, mu n value is 3800 centimeter square per volt second and mu p is 1800 centimeter square per volt second. And in case of silicon, mu n is electron mobility centimeter square volt second and mu p is 500 centimeter square per volt second. Okay, and also one more point you will see. One more point you will see. Right. Yes. Here you see electrons in case of germanium. Electrons in case of germanium moves 3 times faster than silicon electron. As you see, this value is 1300, this value is 3800, 1300 into 3, okay, 3900, this value is 3 times faster. So electrons in case of germanium is 3 times faster than silicon. Okay, so if mu g in case of germanium is 3 times mu of silicon. Okay, electron hole mobility ratio electron hole mobility ratio in case of germanium mu n upon mu p. This is nearly mu n upon mu p. This is nearly 2 divided by 1. Okay, 2 divided by 1. And in case of silicon, divide its value is 2.8 divided by 1. 2.8 divided by 1. 2.8 divided by 1. Next is right. Conductivity of germanium increases by 6% per degree 6% per degree rise in temperature. 6% per degree rise in temperature. Also in previous slide you have seen electron mobility is always greater than hole mobility. 3800 is greater than 1800. 1300 is greater than 500. So right, electron mobility always greater than hole mobility. So if electron will move faster as mobility of electron is higher. If electrons will move faster, then they will contribute mobility increasing means current. They will contribute more current. than compared to holes. If electrons will move faster than holes, then they will contribute more current in comparison with holes. Okay. Next point, write down in if temperature increases, mobility decreases. If temperature increases, mobility decreases. If temperature increases, mobility decreases. As if temperature will increase, atoms will vibrate. There will be vibration in atoms. And this vibration, atoms will vibrate or thermal agitate as atoms will vibrate. So mobility of charge carrier decreases, and this value is mobility is directly proportional to T raised to power minus m. Mobility is directly proportional to T raised to power minus m. Here m is material constant. And for germanium, in case of electrons, for germanium, in case of electrons, m value is 1.66. In case of holes, m value is 2.33. In case of electrons, this m value is 1.66, and in case of holes, m value is 2.33. Remember this. Okay. And for silicon, for electrons, m value is 2.5. And for holes, m value is 2.7. Okay, we have seen mobility is directly proportional to T raised to power minus m. Mobility of charge carrier decreases with temperature as non-linear variation. This is not a linear variation, as we have seen earlier. X is equal to AT is a linear variation. This is non-linear variation. Okay, mobility of charge carrier decreases with temperature as non-linearly. Mu is equal to drift velocity upon electric field. Vd is equal to mobility into electric field. Drift velocity formula is Vd is mobility into electric field. This you will write in formula notebook. Okay. Mobility. Next, mobility is related directly to mean free time between collisions. This collision, mobility is related to mean free time. This collision is determined by scattering. Is determined by scattering phenomena. As there are two types of scattering. Lattice scattering and impurity scattering. Lattice scattering results from thermal vibration due to thermal vibrations. Lattice scattering is due to thermal vibration of lattice items. At temperature at thermal vibration, due to thermal vibration at temperature greater than absolute zero. Okay, as these, what will happen, these vibration will disturb the lattice potential, as this vibration will disturb the lattice potential and will allow the energy to transfer between carriers So this vibration will increase temperature. As there will be more vibrations, temperature increases. This lattice vibration increases with the temperature. So write it one more point in lattice scattering. These are dominant at high temperature. Okay, these are dominant at high temperature. These are less significant. These are less significant at high temperature. Impurity scattering is less significant at high temperature. What will happen at high temperature? At high temperature, carriers move faster. And they remain near the impurity atom. Carriers move faster and remain at near the impurity atom. Thus this scattered less. Okay. Collision time. Mobility formula in terms of collision time. Tau c upon Mn. Mobility formula you will write in formula notebook. Mobility formula Q tau c upon Mn. Collision time Mn is mass. Okay. Next, write one more formula. Number of collision taking place in unit time. 1 by tau c is equal to 1 by tau c lattice plus 1 by tau c impurity scattering. 1 by tau c lattice, 1 by tau c impurity, and also write 1 by mu is 1 by mu of mobility of lattice, 1 by mu of impurity. Okay, this formula you will write 1 by mu is equal to 1 by mu L plus 1 by mu I. Okay, and this graph you will remember log mu mobility versus temperature. Okay, this is case of impurity scattering. This is lattice scattering. Here positive slope, this varies at t raised to power 3 by 2. Here negative slope, this lattice scattering varies at t raised to power minus 3 by 2. Okay, minus 3 by 2. Next, Next, write one question. Write one question. Write one question. Two scattering mechanisms are given. Two scattering mechanism given. One having mobility 250 centimeters square per volt second. Okay, and second mobility is given 500 centimeters square per volt second. Find mobility. Then Bose scattering mechanism. When Bose scattering mechanism exists simultaneously as we have written formula 1 upon mu 1 plus 1 upon mu 2 1 upon 250 plus 1 upon 500. Mu value comes out to be 160 centimeters square volt second. Okay, and next is drift velocity. This concept we will see in next class. Please tell to your friends if it will be beneficial session for them also. So for today it is enough. In next class we will see the concept of drift velocity. Thank you.